Hi everyone, this is Johannes Schmieder with another video for my series in labor economics. In today's video we will discuss how one can get plausible estimates of the effect of UI benefit extensions on workers' unemployment durations. We will also cover a new empirical method that has been very influential in economics, the regression discontinuity design, to show how this has been used in the context of studying unemployment insurance. The video consists of two chapters. In the first chapter, we will cover the regression discontinuity design and how it can be used to obtain causal estimates of the effects of UI. The second chapter will then illustrate this by discussing a research paper that studied UI extensions in Germany using such a regression discontinuity design. This chart shows again the rise in the unemployment rate during the Great Recession. Remember that we are interested in understanding how much of this increase from December of 2007 to October of 2009 was due to the sharp increase in potential benefit durations from 26 to 99 weeks. Earlier we did some of these simulations using just a spreadsheet program. We showed that depending on what the elasticity E of potential benefit durations, of unemployment durations with respect to potential benefit durations were, we can get different answers to this. For example, if the elasticity is equal to 0.3, the increase in potential benefit durations from 26 to 99 weeks would explain an increase in the unemployment rate of about 2.3 percentage points. That's quite large. That's almost half of the actual increase in the unemployment rate. That means that even if there had been no recession and the only thing that had changed was that Congress had increased potential benefit durations, we would have seen a substantial increase in the unemployment rate. On the other hand, if E is equal to 0.1, a much smaller number, the increase in potential benefit durations can only explain an increase of about 0.7 percentage points of the rise in the unemployment rate, as you can see here. In that case, the effect of UI during the Great Recession was relatively limited. So we would have to know how much the unemployment rate would have increased if UI had not been extended. We thought that for this it's important to have empirical estimates of how P affects the unemployment durations, either in terms of the marginal effect or expressed as an elasticity. Now, how could we estimate this? Well, we need variation in potential UI benefit durations P, of course. This is difficult in the US because usually P is extended during economic downturns. So if you find that the unemployment durations are longer when P is higher, this could just be because P is high whenever it is hard to find a job. This generates the classic omitted variable problem. We will now learn that the regression discontinuity design can help us getting around this omitted variable problem. So let's first cover the regression discontinuity design, and then we'll get back to an empirical example of how this actually has been implemented in practice. Therefore, let's start now with Chapter 1. The regression discontinuity design. We are interested in estimating the causal effect of potential UI benefit durations, P, on the average unemployment duration, D. Suppose you would collect data in the United States on individuals who are entering UI, and you track then how long they are unemployed to run the following regression. D is equal to alpha plus beta P plus epsilon. The problem is in the United States, P is determined by the state of the business cycle. When the economy is doing poorly, P is extended either by the federal government or by state governments. Therefore, if you just estimate this using all S, this regression would likely lead to severe omitted variable bias. The idea behind the regression discontinuity design is that often policies assign a policy parameter, such as potential benefit durations P, based on some characteristic of individuals, such an assignment rule then may have jumps. For example, in some countries, potential benefit durations depend on the age of the person who is claiming UI benefits. For example, consider a situation where individuals who become unemployed when they are younger than age 42 are eligible to 12 months of UI benefits. And individuals who become unemployed when they are older than 42 are eligible to 18 months of UI benefits. This seems a bit arbitrary, but we will see that this actually has been the case in practice in a particular instance. This figure shows the relationship between the policy variable P and age when claiming UI benefits. Since age assigns the policy parameter to individuals, It is often called the assignment variable when we talk about a regression discontinuity design. Note that the relationship between the policy variable age and p and the assignment variable age has a jump at age 42. We can also say that there's a discontinuity at age 42. This is where the name regression discontinuity design comes from. Consider individuals who become unemployed one day before they turn 42, and compare them to individuals who become unemployed one day after they turn 42. Most likely, these two individuals here and here are on average almost identical. Whether one becomes unemployed a day before or after one's 42nd birthday is likely as good as random. The only big difference is that the second group receives 6 more months of potential UI benefits. Suppose we now created a scatter plot of unemployment duration and age. What would this relationship likely look like? Well, in general, unemployment durations may vary with age. For example, unemployment durations may increase because older people take longer to find a job. But its increase should be smooth since age increases gradually. Now suppose that there's a jump in unemployment durations exactly at age 42. If otherwise the relationship between age and unemployment durations is very smooth, then the jump in unemployment durations D at the threshold or at the cutoff of age 42 is likely because of the increase in UI at age 42. The idea is to use this jump then to get an estimate of the change in UI here on the unemployment duration D. The idea of the regression discontinuity design is that this jump here provides a causal estimate of the effect of increasing P from 12 to 18 months then. In the setting described here, we can obtain an estimate of the causal effect of P on D by comparing people just to the left of the discontinuity with people just to the right of it. This method of using a policy discontinuity to estimate a causal effect of the policy is called regression discontinuity design, or also called RD design, or sometimes RDD, as the acronym for all three words. This method has become very important in economics. The idea of the regression discontinuity design is that people to the left and to the right of the cutoff are essentially identical on average, except that they have different UI eligibility. But what if people to the left and to the right of the cutoff are different? For example, it could be that some firms are more likely to lay off workers who can get more UI. If these firms have different workers, then individual characteristics could change at the cutoff. In principle, if there are such differences, these could also lead to a jump in unemployment durations at the age cutoff. This is essentially a form of omitted variable bias. The key advantage why the regression discontinuity design has become so popular in economics is that it is possible to test the validity of the RD design. Suppose firms are more likely to lay off workers who can get more UI benefits. What should we observe in that case? Well, clearly there should be more people entering UI just to the right of the eligibility cutoff. But this is something we can easily observe in the data. We simply have to calculate how many people become unemployed at different age levels, and then look at whether or not the number of unemployed increases at the age cutoff. This figure shows how this might look. Note that we again have the age when becoming unemployed on the x-axis. Each dot now represents the number of people who become unemployed in a 1-year age window. For example, this dot here would suggest that there are around 420 people who enter unemployment when they are between age 40 and 41. This kind of graph that shows the number of observations, but some other variable, is often called the density plot in statistics, and the dots are an estimate of the density at each age. Note that in this graph there is no jump in the density. This suggests that people to the left and to the right of the cutoff are not differently selected. If on the other hand the figure would look like this would indicate a problem. This might be the case because firms prefer laying off people with higher UI eligibility, but in that case individuals to the left and to the right of the threshold may be different in other ways. They could influence the unemployment duration. In this case, we would be very skeptical whether the regression discontinuity design really gives us a good estimate of the true causal effect. There's a second test to check the validity of the RD design. Suppose workers are selected differently on both sides of the cutoff. What should we observe in that case? People to the right of the cutoff should look differently along many other dimensions. But often we can observe other variables in our dataset. We can therefore check whether along other dimensions people are different to the left and to the right of the cutoff. Suppose that we generate a scatter plot, but instead of the unemployment duration, we show the average wage before people become unemployed on the y-axis. Notice that since this is the wage before people become unemployed, potential UI durations cannot have a causal effect on this variable. If the figure looks like this, like it is shown here, then there's no jump in pre-unemployment wage at the age cutoff. This would suggest that people to the left and to the right of the cutoff seem very similar. Ideally, the same would hold for many other variables, such as education, people's experience, whether they are married or not, gender, and many others. If, on the other hand, the relationship between the pre-unemployment wage and the age when becoming unemployed looks like this, we should be concerned. The jump indicates that people to the left and to the right of the cutoff are different, and therefore don't provide a good comparison to estimate the effect of potential benefit durations P. Let's put these things together. Here's a guide for estimating a regression discontinuity design. For an RD design, we need a policy that depends on a variable such as age and jumps at a threshold. Every RD design has the same key steps. First, we want to test the validity of the design. We need to show that it is random on which side of the threshold people land. For this, we do two tests. We show that people do not seem to bunch at the cutoff, or there does not seem to be a jump in the density at the cutoff. And the second test is we show that other characteristics of people do not jump at the cutoff. Then we show the first stage. For this, we showed that the treatment or the policy variable actually jumps in the cutoff, and by how much. So we want to show, for example, that potential benefit durations really increase at the age cutoff. This is usually pretty easy to do. And then finally, we want to show the effect of the policy on the outcome of interest. We want to analyze whether the outcome of interest changes at the threshold. If so, we can use that to estimate the causal effect of the treatment variable on the outcome of interest. The regression discontinuity design can be a powerful way to obtain credible causal estimates of the effects of a policy. The key advantage is that we can test the validity of the RD design. In a standard regression design, this is much harder to do, and it's very hard to rule out omitted variable bias. This method has been applied in many contexts in economics. For example, economists have studied the effect of student-teacher ratio on test scores or class size on test scores. They have studied the effect of being a Vietnam veteran on earnings. They have studied the effect of various scholarships and college attendance, and many, many more.